The idea of this talk is, okay, like read or not to read the code. Any ideas? Like who thinks that we don't need to read the code? Okay, done. Like, I mean, yeah, like I'm done here. Because yeah, I think you should, absolutely should. Few words about me. So I'm in a bit of a lucky position. First of all, yes, my name is Anton. I lead platform engineering at the company called Actable. We build Jira for hotels. Very fun, super interesting. Not hiring at the moment. And I have time to like oversee DevOps, infrastructure, a bit of architecture, and have time to tinker a bit with things, not pressured by deadlines or something. And I can observe how other teams at our company like embrace the slope. What do they do about it, and what are the repercussions? I have a thing to say, like to confess. I'm the closest to a burnout that I've been in my whole career. Like this AI fatigue is real. The burnout, like, yes, I work much more, and I think a lot of people feel the same. And FOMO, of course, not gonna make it. Like, it's really hard. It's really hard, at least for me. And in the meantime, what makes it even harder is like conflicting message from the industry. Like on the first side, like there are these people, like they are generating code at enormous amounts, like speeding up, 24 agents running all the time, 5 monitors, etc. And like that's my machine. Like this is where I code, and like I don't have a lot of monitors, and 2 agents is my limit, like the front and back end, something like that. Also, yeah, like I mean, how many 9s are on this screen? Probably like at least 5, so all good here. And I was trying to think, like, okay, what do I do with that? And a small caveat about this presentation, it's backwards. So because, you know, I'm standing between you and hanging out, pizza, beer, and etc. So I'm prepared to stop at any time. So the most important content that I believe is the most important one is at the beginning, and the rest is just, you know, fading away. So while thinking about what do I do about that, about like my burnout, this AI fatigue, all this kind of like conflicting messages, I realized you need to talk to people. You need to ask like what's going on, like what's your opinions. You visit events like this. Also, you watch YouTube channels, and I recently discovered this AI engineer. It's a conference, YouTube channel, website. If you are unaware, go there. A lot of great content that like helps you understand what's happening around you. Because it's on my closing slide as well. The thing about AI right now is that no one knows the answer. They pretend they know, like, you know, at least in my opinion, but they don't. And if you come up with, like, if sitting at night at an office or being overtime, trying to like imagine the size of the PR, as the previous speaker said, like, and you're trying to like, what do I do with that? I guarantee there are a lot of people at the same very moment thinking the same. And we all face the same problems. That's why right now, because, you know, it's evolving in front of our eyes, there is value in talking to each other, because this is it. This is when the history is like being created. And, you know, no one knows the future. Maybe one of us is the person who comes up with the next, you know, hype cycle. So, having said that, the most important slide. Let's zoom out a bit and like back to the classics. I'm a fan of this book. The book is The Goal, but actually like gold Goldratt. He is the creator of theory of constraints, and he shared like a thing. How do you, as the whole, adopt a new technology? And there are a few questions, 4 questions that you need to ask. First of all, what does it do? And for AI, I think the answer is like, I don't know, in my opinion, it types really fast. What limitation does it address? How does it work? Token in, token out, slop in, slop out, but it types much faster than me. I was the limitation. Now I really like 37,000 lines of code per day. That's probably would be hard for me, but there are people who can do that. So really, this is the limitation. And how do we currently cope with the limitation? We review each other's code. We help each other to we are using libraries, frameworks. I don't know. We learn, do best practices, and the last one, establish new rules and behaviors. This is the most important question, and I will explain it in a bit. First of all, usually when adopting a new technology, people answer only the first 3. And the last one is like, who cares? With AI, that's what I see. That's what other people tell me, like too much slop, that factory. There are a lot of researches that, yes, productivity is kind of going up, but the reality is that it's a lot of rework. So you're reworking the slop that someone or you generated last week, all that kind of stuff. Though, some people say that, yeah, I'm extremely productive and it's quality code, but if it's not, then tomorrow's models will definitely figure this out. Okay, sure. Let's think about these observations. Where are they coming from? They're coming from how do LLMs work? How does this technology work? And we are starting to learn, overall, the limitations of the new technology. It's not bad. It's just the limitations. Everything has its application scope. So first of all, they're stateless. So they forget everything. Whatever you tell them, you start a new chat and you start from scratch. Also, the context is limited. On average, 400K tokens. Some claim there is a 1 million. There are research saying that actually better not to use this 1 million. So 400K looks like reasonable, soft constraint. What's interesting about that? I suspect even my side project will not fit here. 400K of tokens, it's really not a lot. So you cannot just shove the whole code base in it and hope that it will, make the best decisions. Also, this is the limited instruction budgets. It's kind of speculation, but people are arriving to this conclusion that really there is a limit of the number of instructions you can give to an LLM, and then that it would reliably follow it. It is improving, but marginally. And so the sweet spot, again, that's a speculation, so a few hundred. There was a research, but it's already a bit outdated because it was Sonnet 3.5 or something. So it was around 100 to 200. So obviously, likely, new models are much better in it. If you exceed this budget, the model degrades. And the better the model, it will degrade slower. The cheaper the model, it will just boom, nothing, at all. And overall, we can summarize it that there is this thing that happens over time, which is context rot. So for some reason, it rots. It's digital world, but, it degrades. The idea here is while some people say, okay, LLMs, next generation LLMs will fix the code of the previous generation LLMs, that's, if we want to escape the Slopacolypse, then let's figure out how to make the best of today's model. And looks like, given the limitations that I outlined, This is all evolves around context, managing context, and this is why there is this new term called context engineering. So rest in peace prompt engineering, and long live context engineering. As a summary, the context is like text in, text out. So this is my drawing of the no AI here. Hand painted, not painted, it's Xcali draw, like 5 hours ago while sitting on another presentation. Overall, in the context, so system prompt, all the tools because it's text, and then how many MCP servers everyone uses? 10, 20, 50? All they go somewhere here because it's again text. And then you tell it, okay, let's build some cool stuff. And yeah, the response is, yeah, you should really walk to the car wash. And the response is, yeah, you're absolutely right. And we all know that when it says you are absolutely right, that's probably what you definitely are. But you need to restart. And so this is this emerging term, smart zone and dumb zone. And the consensus here is that around 40 to 60% of the context size, this is where the threshold is. So if your model's context size is 400K, so half of that, if you're at 200, then probably it's time to start considering to start a new chat, do something else, because the quality of answers will go down. To summarize what can go wrong here, if we try to categorize in categories, the absolute worst thing that can happen when you are trying to use AI-assisted programming or agentic programming, incorrect information. So the model makes a mistake, you correct it, you figure out that something was really off, the model makes mistake again, you correct it, and what happens next? Yes, the model okay, I need to make a mistake because this is how we roll. That's incorrect information. It really derails the conversation and makes the agent distracted. And you can test it speak about, I don't know, horses, and then at the end of the conversation, in your Android code bases, you will see horses. Then the next one is missing information. It's not the worst, but there is a catch. Imagine you did not specify how you are going to build a feature. Maybe you are going to tell it, let's migrate our navigation system, and that's it. AI it's trained on the code from the internet, my code included. So it will okay, the human didn't tell me the framework, anything, so yeah, I will do Swift UI, why not? You probably don't want that. And the last one is noise. Noise is not super terrible, but at least it consumes context and this, smart zone and etc. And the noise is not you doing something terrible in the conversation. It is those tool calls, parameters to tools, output of the tools, reading files to understand your code base. All this noise, this is hidden, but it goes there. And yes, as I already said, the result is you're absolutely right. So AI just becomes dumber and dumber. So what about new rules? How do we, so this is the fourth question. I'm trying to answer the fourth question, and I think this is the way to escape the Slopacolypse. And we need to figure out the direction. What would be the new rules? What based on the limitations of the new technology? And yes, it's super obvious, super simple. We need to creatively escape the dumb zone. That's the second most important slide of this presentation. So start context more often, keep it fresh, keep it short. Then do a thing called progressive disclosure, which is don't try to tell it everything, all the best practices, guidelines, all your code base. It will distract the agent. So give the absolute minimum of the information, give it a map, some ideas, and allow an agent to discover the rest. So this is how skills work. And smart compaction, smart compaction. So you do the compaction. So when you see, when you're finished with the task, but you really believe that you need to use this artifact and continue the session, do the compaction, remove the noise, save your session to an empty file, start fresh, give it this empty file, like, hey, this is the result of our research, let's continue. Then, what goes next? Yeah, sure, of course. Like, I mean, don't outsource the thinking. It's probably the root of the answer to read the code or not to read the code. Like, LLMs, they always do only 99% of it what you asked. They introduce like 1% of slope all the time. And eventually, your mental model diverges from the real code. And especially if you did not participate in the making decisions, in reading the code, like 3 a.m., dissatisfied customer, something doesn't work, someone is paged, 3 a.m. of Saturday or Sunday, something, and like, good luck to fix that. I don't know. I mean, really, it was an LLM to write this code, so you can try to ask an LLM to fix it. Maybe it will succeed, maybe not, who knows, really. Then keep LLM unbiased. This is actually also very important. And what I mean here is that, for example, when you're doing research, you can do it, and by research I mean, let's look at our code base and understand how the authentication works. So because your ticket, your task is to integrate with social networks, like something like that. You only have username, password, and or only anonymous, and you want to introduce some real authentication. So you can either tell it, let's do this research, understand how code works, how the data flows, and all that kind of stuff, the key files and etc. in the current code. Or you can tell it, I'm going to introduce Google Authentication or like Firebase. Please take a look, like how it works, so that I can do what I want. And in the first scenario, the LLM will give you facts. It will search for the answers and give you like unbiased, factual representation of your code base. In the second one, it will already know that what you are going to do. So whatever it will be looking for, because of context rot, because of how they work, attention mechanism, etc., LLM will inject the idea, the architecture of your upcoming feature, but you're only doing the research. So the research will come up biased, and you really don't want that. Then the last one is seek leverage. So AI can type fast. How can we use that? How can I type less? And what can I do right now with the least amount of energy, least amount of my time, because it's much more valuable. And then, so that the AI runs for the whole night, hopefully, and then, produces what I wanted. So instead of, steering it all the time, reviewing all these lines of code, and etc., like where can we inject ourselves to have the biggest leverage? Word of caution, that's already well known with the industry. So LLM is, or AI, is an amplifier, and that's important. So if you have good practices, good code base, the result will be fascinating. If your code base is like mine, and remember, so my code bases are a lot of public ones, so if you don't tell AI how exactly you want to see your feature, it will think based on my code. Don't recommend. Okay. Let's skip this slide, it's very boring. Surprise! Like really, yeah. Like, I mean, nothing has changed. What we've been learning for all these years, and like the previous generation and the other one, it still holds true. Because of the fact that AI amplifies what's already there. So if, as I said, if the foundation is good, then it will it really will be a great leverage. It will really type fast based on all these best practices and etc. that we already have. And that's what we want. This is like how you avoid slop, because good code means not slop. The third, probably most important slide of the talk. Okay, fundamentals, sure. I tried to summarize the most important fundamentals that influence you working with AI. So first of all, we all know domain-driven design, and the biggest pillar of it is ubiquitous language. So we inside the team talk the same language, our product manager, product owner, business analyst talk the same language, clients talk the same language, and this language is in the code. So AI talks the same language, reads the same language, and so when we are trying to align on the research on planning, we use the same vocabulary, and there is less variation, so less chance for AI to make a mistake and treat a user as a customer, which kind of looks like it's the same, but actually it's not. Then vertical slices, deep modules, doesn't need probably a lot of introduction. So make your modules deep, not shallow. So hide as much complexity as possible. Give it like a understandable, easy to understand interface. And try to, do it vertically. Interesting thing about vertical slices here is that probably a lot of people already noticed if you just like do a brain dump into an LLM session and you're building end-to-end application like mobile client, the backend, some database changes, how it would, and the bigger, and if it's a big feature, the first step that AI will do, it will like, okay, let's build your whole database. Then let's build your whole backend and all the APIs, contracts, and etc. Then it builds the mobile app and nothing works because of some tiny mistake somewhere in the beginning. And so this is where vertical slices come in, telling it like, let's build a slice of authentication. Let's build a slice of a list of this thing. So build one table, one API, one contract, and one screen. Then ongoing investment in the code-based design. So AI types fast. You don't need to type if you don't want to, but you need to focus on all this high level, like how modules work with each other, how easy it is to understand, how complex is your code base, because AI kind of has a limited capacity on the complexity of your code base. So you need to keep it tidy and continuously simplify, simplify, simplify. And the last ones are kind of related to each other. So feedback loop. And this is probably the reason why AI shines the most in software engineering, is because we have linters, static code analysis, automated tests. So when AI mistypes a function name, it doesn't compile. So it has this feedback and it's like, oh, yeah, sure, changes it, and finally it produces something useful. So making an investment into all these validations, making sure it can run locally, it can run fast, gives you great results. The next thing, aside fundamentals, so as I said, I tinker around, hopefully I'm using this word properly because I'm not a native speaker. I was looking around what the industry is doing, and I noticed few people converging on the same thing. First of all, overall, with AI, I think there are two major ways of doing it. The first one, you do an interactive session. Sometimes you do it because you don't know the end result. Like, we are experimenting, building a POC, something, so you cannot plan ahead. It's very mentally exhausting or impossible at all. Or you don't know the direction, like how this API would look like, how would it change my code? Let's try, give it a test and see what's going on. Or sometimes, you know what you're doing, you're just lazy to plan ahead, or you don't think that it's needed to plan ahead. And so there is this guy, I think he says that you should pronounce his name Fei. He came up with this thing called load coding. Absolutely go to this link, read his blog post. It's a system prompt. You can convert it into a skill. What it essentially does is that gives AI instructions to capture your decisions that you are making in the session, outline them in a map, so progressive disclosure, maintain this map, try to maintain the consistency of these decisions, treat the code as a source of truth, for sure, that's like invariant. And when you start a new session, it loads the practices, the terminology file, the map file. So again, terminology, again, super important. And it's not super stateless afterwards. So you can continue your session, and it already knows that we are using this API here, not because we kind of don't know what we are doing, but it is some decision made some time ago during a session because we had to, like some kind of an ADR, but this is for AI, being maintained as you go by AI for itself, so that it doesn't forget about your code base. It's not magic, it's a workflow. It will not just work, like, you tell it, hello world will be a dope feature. No, it will not do that. You don't outsource the thinking, and this approach will help you to be faster than a person who is not using it at all. Then there is a second approach where people try to plan ahead. And that's an interesting one. First of all, it's sarcasm. Like, I mean, don't dive deeper into those things. It's a lot of people like coming up with these things. They, I think, basically do the same thing. It's about let's plan, specify what we are going to build. It's not a plan, it's a spec. Then split the spec into phases, then ask AI overnight or whatever to implement it, and let's hope that it works. I think this workflow is where you get the best leverage. So the load coding or something similar, this is for interactive sessions, not only for exploration, so it's a very healthy middle ground. Here, the biggest leverage. This is the fourth question from the beginning of the talk. And that's the reason why I'm burnt out. And a lot of you are burnt out. And AI fatigue and etc. And some of the research plan implement, if you Google it, you will find a guy, I cannot pronounce his name. It's the company Human Layer. They are helping others to do AI and make this AI work in complex brownfield code bases. And he said that it took them 8 weeks. And it was a complete beep, beep, beep. But they're not going back. So this is really the fourth question. So how do we behave differently? So AI lifted the limitation of typing, like making some predictable decisions, doing big chunks of work. And if we just embrace it, we will embrace slop. If we change our workflow, build our workflow around capabilities of AI and around its limitations, this is the leverage. For a starter, there is this guy, Matt Pocock. He came up with some few skills that kind of help with this workflow, so really worth checking out. He has a web page, YouTube channel as well, shares a lot of cool stuff. Worth checking out. Let me explain the foundations of the workflow. I don't know the answers. We are, coming up with the answers as we go. We try, test it, we see what works, what doesn't work, but the foundations remain the same, and so this is the general idea. You do a session, like you start researching or something, you do a session trying to be unbiased, asking for facts. Then you try to get in alignment with AI on what you're going to build. And for example, in the collection of Matt's skills, he has this skill called Grill Me. So it fires up a grill and asks you questions like, what are you going to build? Are you sure? Like, how is it going to work? This is not going to work. Did you think about that? No, but, and if you do that and the moon shines, then it's like really like 40 minutes, 1 hour or something for a very simple feature. But you get alignment and leverage that, maybe not leverage yet, but essentially, this is your context. And all the knowledge about what you're going to build is here in the context. And at the end, you're doing the smart intentional compaction, and you tell it, forget the noise, forget the, the tool calls, forget this blah, 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 and distill the knowledge of our research into an MD file. You start your fresh context, and you like, here is our research, this is how our code base works, this is what we want to achieve. So let's plan phases, like let's make sure we do vertical slices. Let's make sure each phase can be tested, acceptance criteria, whatever. AI doesn't care about all of this. It only has this distilled research. You figure out the plan. Very important. This is not like waterfall, big design up front or anything. This is agile. So when you do this, like I have limited capabilities in drawing diagrams, but it will be hundreds of this. And it is okay to tell AI, no, you're wrong. Like, this is not how it works. You missed this file. And you actually did not conclude that we are doing it like this because of that. And the load coding method kind of helps this because some of these relations or technical decisions are already in the context in this load thing, like in a markdown file, so it will help AI to infer the relationship. And the same applies to a plan. It generates a plan, like if you just approve it and let AI go, it will be slop, even if you did the research right. So you look at the plan, it's like, does it make sense? Like you are, when I was playing with this, and I told it, let's implement the billing to my side project thingy, and it's Android application, by the way, in Compose multi-platform, because I'm only one person, so I had to do some multi-platform thing. And I said, like, okay, let's introduce billing and let's start charge people. And the AI, like, sure, yeah, here's your plan. Here is a list of user stories. As a user, I want to pay for this app. No, a user doesn't want to pay for the app. Like, literally, no. That's me who wants that. And so I told this, you're wrong. And it was, okay, as a system owner, you want your users to pay for the app. Yeah. And then I said that, but right now, we are blah, 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 something. Let's mock an API or like do some simple thing, and then eventually we will do the proper Stripe integration or something. And AI came up with a user story. As a future Stripe integration, I want this API to exist so that I can call it and make the real billing, whatever. Yeah. So again, multiple iterations on each phase. And then once you're happy with the plan, with the phases, they don't contradict with each other, they really deliver value incrementally, atomically, you can test each of them. This is, TDD and proper user stories. You again compact it into the plan MD, start a new context, and then tell AI, okay, crack on to phase 1, cross out the items that you complete, do a commit, and tell me that you're done. So that's overall the workflow in a nutshell. Let me see if there is facts, not opinions. Already said about that. So when you're doing research, try to be unbiased, just like, hey, how my code works. And don't tell AI your intention. And so this also applies to, like, probably you should not be telling AI, do a research, and here is the link to a Jira ticket. So, do a research based on the intent of this ticket. Maybe do another session like, hey, there is a ticket. What questions should I ask to do a proper research of the code base, to touch all the components of the code base that will be affected by this feature. Once you get the questions, then spin up the research and let's answer those questions. But don't tell the ticket, don't tell it about the intent. Then the planning phase, vertical slices, not horizontal. As I mentioned, AI loves to the whole database, the whole backend, API layer, client, whatever, and then nothing works. And a feedback loop. So it will make mistakes. You need to tell it how to course correct. And actually, I recently enjoyed very much. I was reviewing one pull request. Oh, it was 3,000 lines of code. I read everything. I am the person who reads everything, even marketing materials. And few vendors did not get a contract because I just read what they claim and tested it. And so I noticed that AI loves to do fully qualified names of Java Kotlin classes, like Java util collections, blah, blah, blah. Okay, that's kind of slop. And if I see it in APR, probably the person did not read the code. And I was like, okay, what do I do? And I realized, hopefully I'm the only person here. I realized that for the front-end code bases, when it's TypeScript, JavaScript, you always have ESLint, Prettier, whatever. When it's Java, Kotlin, you have none. By default, only have tests, but static code analysis. In my code bases, for some reason, I don't know why, just never thought about it. And so okay, I need to introduce a linter. It didn't work. I told AI, I want to catch this specific behavior of an LLM. What can we do about it? And it patched the PMD, introduced the custom rule, wrote it. I was super happy, created a pull request, and the AI code reviewer built my coworker using the simplest Claude model, Haiku. He told me that it doesn't work. I forgot about one edge case, and I didn't know how PMD works, AST, all that kind of stuff. So I really missed it, and it caught it. And so I made a mistake. AI code review caught a mistake in AI-generated code that is a linter for AI-generated code. This is the kind of feedback loop that you want. And the kind of leverage. I felt ashamed, but in the meantime, we suffered through it, and there is no such issues anymore in our new PRs. AI, when it writes the code, runs the linter, because it's in the practices MD from load coding, it tells always run the linter, always run the tests. And our new stuff catches it, and the quality of our code is kind of not degrading that fast. That's pretty much it. The last slide. The history is happening right now. I don't know the answer. At least I don't know them. I'm trying to, I know how to talk, so I'm talking, sharing what I see in the industry. I really believe if you're stuck with AI, there are a lot of people who are stuck with AI, and they have the same problems and the same questions, because there is no recipe at the moment. The recipe is being created, and one of us, a lot of us are creating those recipes. And it's not clean code book, it's already written. Nothing to add there, but clean code for AI, or best practices to do AI, especially given the 4 questions and the last question about new rules, new limitations. This is, as we speak, the industry is figuring this out. So talking to each other, acknowledging that we are all in it together, and doing it. Do it, build a muscle, and next time it will be easier. Right now it's pain, but eventually you will find the leverage. There will be less slop, and you will be able to ship more, build more, and satisfy your customers. That's it. No more slides, because the last one I moved to the beginning.